Hello everybody, today I wanted to talk a little bit about problem-solving methods in physics and ways to take the problems that you're going to be doing in this class and learn how to take them to the solutions. I want to point out that in this class, yes, we're going to be talking a lot about physics, but we're also going to spend a lot of time learning how to solve problems. And that requires a problem-solving method, and this problem-solving method will be useful I think in pretty much any class you take, especially in physics, science, and engineering. But it can also help you learn how to analyze and solve problems outside of physics and science. So what I'd like you to do when you're working on your problems is set up a work area. I like to have my paper. I like to have a ruler or a straight edge because it's good for making drawings and making graphs and diagrams. I like to have something to write with and an eraser, although you can use a mechanical pencil. This is a friction pen, which I like because if you like to write in pen, it still erases, which is good. Anything you're comfortable with. You can use regular pen too, although if you make errors, you have to be careful about how you correct those. You'll want to either probably rewrite the solution once you've figured it out, or find a way to incorporate it into the solution so it doesn't become all scratched out and becomes a mess. So we're going to be talking about solving problems and coming up with a method. I have a particular method that I like to use. A variation of that is described in your textbook. And in fact, if you go to page 33 in your textbook, it talks about kind of the three parts of problem solving. The first one is setting up a strategy for problem solving. So if you have a problem you want to solve, the first thing you want to come up with is a strategy for solving the problem. The second thing you want to do is work on the solution. And then the last thing you want to do is address the significance. So what does your solution mean? And I would say that these three areas are probably equally important in problem solving. Setting up a strategy, setting up a solution, doing a solution, doing the mathematics, and then addressing the significance of the problem. So as far as under the strategy part, I like to break this up into two parts. One is the model that I want to use to solve the problem. This is basically the type of physics or the area of physics that the problem falls into. This could be something like conservation of energy or projectile motion or rotational motion, because it isolates kind of the area of physics we want to focus on. The second part of the strategy is visualization. So that's where I want to draw a picture. So this would be drawing a picture or some kind of diagram or a graph, right? Something like that gives us an idea of what this thing looks like, right? Now, oftentimes in physics, we can picture what it looks like. So you can just draw a picture of the problem if it's a ball rolling down a hill or something like that. But sometimes it's a little bit more abstract, and you might draw a diagram that illustrates the forces on an object, or you might draw a graph that tells us how something varies over time. And then the last thing that I think about in my strategy is I want to write down the data that we have. What data do we have about the problem? What are the knowns? So what sort of things are given in the problem? What sort of things can either be measured or have been measured and given in the problem? But also to identify the unknowns. What things would we need to measure or estimate or calculate, right? By writing these down, you can get an idea of what direction this problem's going to go in. So that's what I sort of see as the strategy. And frankly, I think that's something you can do with every single problem right out of the gate. The first day you get the problem set is just sit down with all of the problems and write down what area of physics it's addressing and draw a picture of it, write down the knowns and unknowns, things like that. The second part of this is the solution. This is where we're going to look at what equations we might need. We might do some kind of dimensional analysis. right? Something to figure out how these different knowns and unknowns go together. And this is where we're going to do any algebra and calculus, and geometry, with the goal of eventually getting a numerical value and units. The units are important because they tell us whether or not our numerical value makes any sense. And the numerical value kind of starts to give us an intuition about these different problems. If I have a ball falling from a ledge, what speed does it get coming down? Having a visceral sense of what that is really helpful. And then probably the most, I'm going to practice my erasing here, look at that. Probably the most important thing is once you've done these two parts is addressing the significance, or sometimes I like to call it assessment, assessing the solution. So these are questions like, does it have the correct units? Is it reasonable, right? Does it make sense? Does it do what you expect it to do? If you were to take it in the limit of an extreme case, does it give you something you expect? For example, if I'm dropping a ball and there's air resistance, does it reach a terminal velocity, or does the velocity seem to increase? Is there a problem there? This is where you can identify problems and then rework the solution if you have to. So these are the methods that we're going to be focusing on, and my grading scheme for the homework assignment really follows this. We're going to be giving a lot of credit to this process, right? This process of identifying a strategy, making a model, visualizing, doing a solution, and doing the significance. And I should point out that the correctness of the solution is not the most important part, right? Paying attention to this process, being neat and methodical in how you identify it, assessing your solution, that's going to get you most of the way there. And the reason I say that is because if you can identify the strategy and you know the significance, you can even make some back-of-the-envelope estimates of what the solution might be. As you go further and further in your career in science and engineering, the solution part is something you're probably going to hire other people who are expert in that area to solve. So you might identify a problem that you have and you'll say, I know what the problem is, I know what we need to do, I understand what I think the answer should be, but I need to hire an expert to actually work the solution. So being able to identify it and put it in those terms is really, really helpful. So that's what we're going to be doing for this class in this these problem-solving strategies. And what I'll do as we go forward in the class is as we solve problems in class, I'll follow this model so you can see it identified.